Hello, ladies and gentlemen. My name is Ronald Stenzel. I work at the Institute of Computer Technology at the Technical University Vienna, and I welcome you to my presentation about the work-in-progress paper Usage of Clustering Algorithms for Analysis of Radio Maps for Localization Using Directed Antennas. In the project where this paper originated from, we work on the problem of indoor localization. Since there is no standard for this task, like GPS for outdoor localization, the search for an ideal solution is still ongoing. What we propose is the use of directional antennas and a fingerprint method with received signal strength values. Usage of directed antennas could increase the localization performance and suppress disturbing effects, yet dramatically increase the complexity of localization, especially in large-scale networks. We try to solve this problem by using the aid of machine learning in the form of clustering algorithms. A first approach was to simulate a two-dimensional plane with 4 directional anchor antennas, one in each corner. The anchor objects are marked as green triangles in this figure. All of them point in the middle of the plane. At every sample point, the value of the best 3 anchors form a fingerprint. The fingerprint was cumulated in one discrete value, ranging from 0 to 20, where 20 represents the best reception and 0 connection loss. On this well-covered plane, the best reception is found in the middle, while the reception gets worse at the edges and the corners. The sum of sample points with the same RSS value was the input data for the clustering algorithms. For our clustering needs, we chose 2 commonly used algorithms, k-means and mean-shift, and compared their performance. While mean-shift decides the best number of clusters itself, k-means needs the number of clusters as input. Since the task of the clustering algorithms is the division of the plane, we used k-means with an increasing number of clusters to be formed iteratively until the size of every formed cluster fell under a certain threshold. This behavior can be observed in the plots. While k-means creates numerous smaller clusters of similar size, mean-shift creates very differently sized clusters and sometimes very large ones. It is still ongoing work to decide which properties the clusters must have to support the following localization algorithms in the best way. We wanted to test the behavior of our algorithms, not just in this simple scenario, but in many scenarios with different properties. Therefore, a scenario generator module was created, which chose from a specific range of plane sizes, anchor numbers, and anchor orientations randomly. With that module, 50 scenarios were created. K-means and mean-shift were compared regarding their computation time. Furthermore, we wanted to test the quality of the formed clusters by the use of scoring algorithms. We used 3 different analysis methods: silhouette analysis, Kalinski-Habarek score, and David-Baldwin score. The results can be seen in the box plots. K-means loses its advantage in low computation time because of the iterative process, but remains as fast as mean-shift. In general, k-means has worse scores than mean-shift, which can be explained by the limitation of the size of its clusters. The number of clusters we get from this behavior does not achieve the number of clusters the 3 scoring algorithms consider to be best. In the future, we must decide which cluster algorithms do fit best for our purpose and which properties the clusters should have. Additional algorithms will be implemented, like HTTP scan and affinity propagation. It remains to be seen how big the benefits of clustering are. We suspect they will show their merits in more significant, more complicated scenarios and tests with real hardware or dynamic situations. In the case of a moving target which needs to be tracked, a lot of data could accumulate and machine learning will help to process that data. Especially HTTP scan promises a lot of potential for tests with hardware because of its noise suppression. As you can see, the lack of technology standards for indoor localization provides a lot of space for ideas and much work for scientists and engineers. Thank you for your time and attention, and I'm looking forward to the Q&A.